So we look at the solutions to problem set 16 here. What is the sample space if we toss a coin twice? Well, that's just a list of the possible outcomes. So head head, head tails, tails head, tail tails. Show the sample space if we roll 3 dice with a Venn diagram. So we're tossing 3 coins. Each can be either head or tails. So there are 2 possibilities for each toss. How many red cards are there in a pack, which are also face cards? So Jack, Queen, King, or Ace. Show this in a Venn diagram. How many face cards are not red? How many red cards are not face cards? So here we have a messy Venn diagram. So there are 26 red cards which are in this bigger oval. 18 plus 8 is 26. This side oval of 8 plus 8, which is 16, are the face cards. So there's Jack, Queen, King, and Ace for each suite. So 4 times 4 is 16. So this oval represents the face cards. But there are face cards which are red. So there are 8 cards which are both face cards and red. So we can show that with a Venn diagram. So you've got diamonds and hearts. 4 face cards for each of those. That's why you have 8. So that way, with Venn diagrams, we're able to split the numbers we're talking about to segment it into the various little blocks that we're interested in. And you can kind of check whether things are okay by kind of going, okay, 8 plus 18, yeah, that adds up to 26, which is correct. 8 plus 8 is 16. Well, there are 4 face cards for each suite. 4 times 4 is 16. That's what we expect. So in this case, we can go, how many face cards are there which are not red? Well, that's going to be 8. Because these 8 are face cards which are red, and these ones are not. And how many red cards are not face cards? Well, that's going to be 18. Because there are 8 red cards which are face cards. How many outcomes can we get if we roll 5 dice? So we can get 1 to 6 from the first dice, and we can get 1 to 6 from the second, and we get a 1 to 6 from the third, and so on. So we just multiply them. It's just an application of the fundamental theorem of counting. So you put 5 red balls, numbered 1 to 5, and 7 green balls, numbered 1 to 7, into a bag. So there's only 1 red ball numbered 1, 1 red ball numbered 2, and so on. It just means that all the balls are unique. Now we pick one ball from the bag. How many outcomes can we have? Show with a Venn diagram. So we're just picking one ball from 12. So there are 12 possible outcomes. So there's 1 to 5 possible red balls, or 1 to 7 possible green ones. So we add them up, as opposed to multiplying them when it's an AND. So here we have the 5 red balls and the 7 green ones. And since they're distinct sets, we have no overlap. So that's how we'd represent our bag with the balls 5 red and 7 green with a Venn diagram. Remember to subscribe to be updated as new content is added. Thanks.